Okay, what is the remainder? If n is equal to 1421, 1423, 1425 divided by 12, this is a CAT 2000 question. Your answer is find the individual reminders, right? 5 into 7 into 9. I know this is greater than 12, so divide by 12 again, you get 3 as the remainder. So your actual remainder will depends on the product of individual remainder. If it is greater than 12, divide by 12 again and see what is the remainder, right? What about 2 raised to 256 by 17? This is again 2000, CAT 2000 only. Something which we have discussed. 2 questions came in that year, right? So both are based on basic remainder theorem concept. So how will you write this? You need to write 2 raised to 256 as 2 raised to 4 divided by 17 format, because when you write in that way you get a minus 1 as a remainder, right? So 2 raised to 4 raised to 64 divided by 17. You know this is going to give you minus 1 as a remainder. So minus 1 raised to 64 will give you 1. What about this question? 7 raised to 84 divided by 342. What is the remainder? This was 99 question. What is the remainder? How will you write? You will write it as 7 raised to 3. You know that is going to give you 343. So 343 by 342 you get a remainder 1, right? So what you need to know is only one thing, that 7 raised to 3 is 343. Or by looking into this number you will get some idea, you will get the clue, right? So 7 raised to 3 raised to 28 divided by 342. And you know this term is going to give you a remainder 1, 1 raised to 28. Anyway your answer is 1. What about this question? 2 raised to 60 by 5. What is the remainder? This is the easiest as you can get. You will write it as 2 square by 5, right? So you know this is going to give you minus 1 as the remainder raised to 30. You get the answer as 1. Minus 1 raised to even number will give you answer 1. Okay, next we will see some typical questions which can be asked from apart from these topics that we have discussed, right? So as of now we just discussed about basic remainder theorem, that if you can factorize the number, right? If you can factorize a number, if you can write in terms of a into b divided by a denominator, your actual remainder depends on the product of individual remainders, right? So you find the product of individual remainder. If it is less than the denominator, take it as a remainder. If it is greater than the remainder, if it is greater than the denominator, divide that product of remainder by denominator again and take the remainder, right? So the same is the case if you can write it as a sum of numbers, then also your actual remainder depends on the sum of the individual reminders. Okay, this is what we have done. So in case of 2 raised to n numbers, we will write the numerator in such a way that when you divide by denominator, leaves plus 1 or minus 1 as a remainder, right? So most of the time you will get directly as the answer. In case of some more numbers left out, you will factorize it and you will apply the basic remainder theorem and you can get the answer, right? What if you get questions like 11 by 7, 11 raised to 95 by 7, like that, 11 raised to 96 by 7, 13 raised to 96 by 7, 13 raised to 110 by 7, etc., etc. Divide by 7 leaves a remainder. What is the remainder, right? This is, what if this is a question? So if you can factorize this bigger number, then you can apply basic remainder theorem and you can solve it. Okay, so how will you factorize it? That is a problem, right? Now here I am going to discuss another concept which can be applied in similar kind of questions, right? So we have already discussed 2 methods, there is a third method, but you don't want to make it complex. Everything depends on basic remainder theorem only, okay? So let's start off with the method. Now I need to discuss 2 concepts here. One is known as Fermat theorem, okay? Second is something called as Euler's number. So if you have some understanding about this too, you can solve any remainder question faster. You don't want to know this as a theorem itself, but you may use this theorem to solve the question. Same way, you may use this number to solve the question. Otherwise, you don't want to bother too much about this Fermat theorem or Euler's number as such. So what is Fermat theorem? Let's take 2 numbers, A and B. Okay, these 2 numbers are coprime numbers. What do you mean by coprime numbers? 2 numbers which is having HCF 1. That means there is no other common multiple. HCF is 1. What are that kind of numbers? If you take 2 consecutive numbers, it will be coprime number. 2 consecutive odd number will be coprime number. 2 consecutive like 1 odd and 1 even number will be a coprime number. If you take 2 prime numbers, that will be a coprime number. Let's take 13 and 7. These 2 are coprime numbers, right? There are no other common factor except 1. 11 and 7, coprime number, no common factor except 1, right? So this is what I mean by coprime number. Now, what Fermat theorem is talking about, that's what we need to understand. See, Fermat theorem is like this. If a number A divided by B, the condition is A and B are coprimes, okay? And there is something called as Euler's number. That means how many coprimes are there less than B. if you take that as the power, let's mark this as another number n. Okay, so what are a and b? A and b are coprimes. What is this n? N is the number of coprimes less than b. Your remainder is always 1. In this case, this is what we are going to use. Okay, so I hope you understood this. What is a and b? A and b are coprime numbers. What is n? N is the number of coprimes less than the denominator, that is the b. Here b. Okay, if you want to write it in terms of numbers, 11 by 7. Okay, 11 and 7 are coprime numbers. What will be this n? This n is the number of coprimes less than 7, that is 6. What are they? 1, 7, they are coprime. 2, 7, they are coprime. 3, 7, they are coprime. 4, 7, 5, 7, 6, 7. These are coprimes, right? So basically, number of coprimes less than that number, right? So number of coprimes less than 7. Now you cannot manually find this out, right? It is time consuming. If you are getting bigger number like 31, how many coprimes are there less than 31? It will take some time, right? So it's better to have a method to find coprime, because we are going to apply that concept to solve this question, right? So how to find number of coprimes less than the number? That's where we are going to use something called as Euler's number. So I am going to mark it as En. En means Euler's number. Euler's number of a number. Okay, let's suppose n is a number. Euler's number of a number means it's actually a number of coprimes less than number. Number of coprimes less than the given number. So basically Euler's number of 7 means what? Number of coprimes less than 7, and that's what 6. So basically this 6 is nothing but, you can put it in this way, number of coprimes less than 7, or you can say Euler's number of 7. I hope you understood. So what I'm going to do now is, I give you a method to find the Euler's number. So once you know the method to find the Euler's number, we are going to apply it in this situation and we can find any answer. So only this part is difficult. Once you understood this, it's over. So let's try to find what is Euler's number, right? So Euler's number of a number n can be found in this way. If you can write this number as a raised to m, b raised to n. A number generally can be written in this way, right? A raised to m, b raised to n. If you can write in this way, Euler's number will be n into Euler's number of that n. I can write it as En. N into 1 minus 1 by a into 1 minus 1 by b. This is what your Euler's number. Okay. So if I need to find Euler's number of 6, I'll write it as E6, which is equal to 6, which is the number, into 1 minus 1 by 2, because 6 is equal to 2 into 3, right? So 1 minus 1 by 2 into 1 minus 1 by 3. What is this? 6 into 1 by 2 into 2 by 3, right? So this get cancelled. So Euler's number of 6 is 2. What does this mean? Euler's number of 6 is 2 means, E6 is 2 means number of coprimes less than 6 is 2. What are they? 1, 6, 5, 6. That's not important for you. What are they? It's not important for you. You just need to know Euler's number is basically the number of coprimes less than that number, right? So you understood Euler's number. So this is the only thing which I want you to understand. Now forget about those things that we have discussed. What you need to know is, you need to know the Euler's number. You just need to know this concept that I have discussed, right? So what is the concept I have discussed? A by B, A and B are coprimes less than, and if the power of A, if the power of A is Euler's number of B, that is EB, then your remainder is always 1. So if I give you a question, if I give you something like this, 11 by 7 raised to 6, what is the answer? What is the remainder? Remainder will be 1. Why? Because 11 and 7 are coprimes. They have no other factors except 1, and 6 is Euler's number of 7. How will you find Euler's number of 7? E7 is equal to, I know n into 1 minus 1 by a. 7 is a prime number, so I have only one thing. If I have a into b, 1 minus 1 by a into 1 minus 1 by b. If it is 30, 1 minus 1 by a, 1 minus 1 by b, 1 minus 1 by c, it will go, right? So here 7 into 6 by 7. What is that? 6. And that's what this. Euler's number of 7 you will get as 6. Euler's number of 2 you will get as 1. Euler's number of 3 you will get as 2. Euler's number of 5 you will get as 4. Euler's number of 11 you will get as 10. Euler's number of 13 you will get as 12. What you can observe here is, I am writing the prime numbers here, right? I am writing the prime numbers here. So Euler's number of a prime number is always 1 less than that of the number. So it's easy if you get your denominator as a prime number, because to find Euler's number you don't want to do anything, 1 less than that of the number. So if I give you a question like this, 13 by 11 raised to 10, what is the remainder? 13 by 11 raised to 10, what is the remainder? First thing that you need to see is these are coprimes, right? 13 and 11 are coprimes. What is 10? 10 is Euler's number of 11. So what is the remainder? 1, right? Now I'm going to extend it. What if this was 20? What if 13 raised to 20 by 11? I will write it as 13 raised to 10 by 11 into 13 raised to 10 by 11. Or I just need a common denominator, right? I can write it in this way also. I just need a common denominator. Then you can apply basic remainder theorem, because this will give you 1 and this will give you another 1. So your actual remainder will be the product of individual remainders. Again you get 1. What if this was 30? You will write it as 13 raised to another 10. So here one more 1, you will get answer 1. Okay. Now what if it was 13? This is the same thing, right? 13 raised to 13 by 11 and power was 10, right? So any multiple of 10, if this are coprime numbers, you know 10 is the coprime. Any multiple of that coprime, right? So I can mark it as 10k. You get remainder 1. So 10, 20, 30, 40, 50, 60, 100, 1000, 2000, 1 lakh, 2 crore, or whatever it is, you're going to get remainder 1. Why? Because these two are coprimes and this is 10 is Euler's number. And multiples means I am just going to write this that many times, 13 raised to 10 that many times. Each case I get remainder 1. So I'll land up with 1. Now, how can you make a difficult question here? I can put some other value here, make it as 3, or I'll make it as 2, or I'll make it as 1. How? It is basically 13 raised to 11 by 11. 13 raised to 11 by 11. So see, if this is Euler's number, you don't want to worry anything, you can just write it as 1. But here the power is not Euler's number. So what we need to do is, I know these two are coprimes, right? So what I'll do is, I will write it as 13 by 11 and make this 11 as 10. So I'll get this much as 1. Then I'll write 13 by 11 again. I hope you understood. So this part I'll get remainder as 1. For this part 13 by 11, it's a calculation part, right? 13 by 11, I'll get what remainder? 2. So what is your answer? 2. Now any question is over, right? So what if I am getting 13 raised to 32 divided by 11? I just need to see these are coprime numbers, right? Then what is this? I need to make it as Euler's number, right? So 13 by 11, if it was 30, basically 10 is the Euler's number. So if it was 30, 3 times 10. So 3 times I need to write. So anyway, this is going to get remainder 1, right? What is left out? 13 square is left out. So basically I need to find 13 square by 11 remainder. 13 square, you know, 169. You can find it easily. Or you can write it as 13 by 11 into 13 by 11. You can find the individual reminders, right? Here you get 2, here you get 2, multiply, you get 4. I hope you understood. This is the easiest method, right? So what I have done is 13 by 7, I have discussed 32, right? Now is it only 13, 7 or 11, right? Earlier I have discussed 11. What if 7? If you see 7, these two are coprime numbers, right? 13 and 7 are coprime numbers. So I need to make this as Euler's number of 7. So I know 13 by 7, if this was 6, if the power was 6, I'll get remainder 1. So what I'll do is 13, right? 13 raised to 6 by 7 will give me remainder 1. 5 such times up to 13 raised to 30 by 7 will be covered. That is also going to give you remainder 1. Because what is that? 13 raised to 30 means it's a part of 6k. That's a series, right? How much is left out? 13 square is left out. Here you need to divide by 7. You can either divide 169 by 7 or you can divide 13 by 7, 13 by 7. So you'll get it as 6 into 6. That you can divide by 7, right? You get it as 1. Your answer is 1. So now I'm going to generalize it. I just told you the method. I'm going to generalize it. How will you do? If it was 11 raised to 97 divided by 7, you need to see the remainder. Basically you need to write this in terms of Euler's number. This 97 you need to write in terms of Euler's number. Then take that series. Completely you can take it out. Then see what is the number which is left out and solve it. Okay. Now how you're going to solve it is, first step, if you want to write step 1, you divide 11 by 7. 11 by 7. You did that. Okay. Now step 2, divide the power of the numerator with the Euler's number of denominator. That's how I'm going to divide that power in terms of Euler's number, right? So 97 by 7 and see what is the remainder. You will get remainder as 1. So up to 96, what does it mean? Up to 96 it's get cancelled because you are going to get remainder 1. We are applying our theorem. It's like this. 11 raised to 96 by 7 will give you remainder 1. What we applied is Fermat theorem. That we understood. Okay. Now how much is left out? 11 by 7 is left out. That's what we are actually going to do. So here step 1 we found 11 by 7. What is the remainder? 4. Now step 3 is your answer. 4 raised to 1. Nothing but 4. Okay. So 3 steps. What is step 1? Divide the numerator without power by denominator. See the remainder. Second step. Divide the power of numerator with the Euler's number. I'm sorry, this is 6. Euler's number, right? Euler's number of 7, 6. I get the remainder 1. Third step, 4 raised to 1. Now why I am getting this? Because 11 raised to 97 by 7 is basically 11 by 7. What is Fermat theorem? 11 by 7. These two are coprimes. Raised to 6 will give me a remainder 1. Okay. If that is the case, 11 by 6k series, any number if I take 11 raised to 12, 11 raised to 18, 11 raised to 24, 11 raised to 30, 36, 42, any such number will give me remainder 1. And 96 belongs to that series. That means 11 raised to 96 by 7 will also give me remainder 1. So up to 11 raised to 96 is covered. What is left out? 11 by 7 is left out. What is the remainder? 4. And that's what we are finding. 11 by 7 is what we are finding in the first step. And second step we are finding how many such 11s are there. How many such 11 by 4s are there. What if it was 98? What if it was 98? Here you will get up to 96 is covered. 11 square by 7. Now how you are getting that? Based on our steps that we have discussed. What you will do in the first step? First step 11 by 7. See what is the remainder 4. Second step 98 by 6. Euler's number of 7. You will divide, right? You see what is the remainder. Then you will take 4 raised to 2. Right? That's what you are getting here. 4 raised to 2. Basically what does this mean? 11 by 7 2 times you need to do. That's what 11 by 7 one time will give you 4. 2 times will give you 4 square. That is 16. So you need to do it again, right? Because which is greater than 7, so you need to do it again. You will get it as 2. I hope any question based on this pattern you can solve now. Okay. So again I am telling you A and B are coprime numbers. That means no other factors other than 1, right? Basically HCF is 1. And what is this? EB is the Euler's number of B. What is Euler's number? Number of coprimes less than B, right? You don't want to know all those things. You just need to know 2 steps, right? What is the first step? Find A by B remainder. Second step, what is the second step? Divide the power of numerator, right? So you will get a power divide with Euler's number of B, right? And you see the remainder and then take that. You will get your answer. So again let me tell you, 15 by 7, these two are coprimes. If this was 6, your remainder will be 1. 15 raised to 12 by 7 will also be remainder 1. Why? Because 6 is Euler's number of 7. So any series if you take now, what is 15 raised to 12 by 7? That is nothing but 15 raised to 6 by 7 into 15 raised to 6 by 7. So 1 into 1. Okay, again you will get remainder 1. 15 raised to 24 also will give you the same. 15 raised to 48 also will give you the same. That means I can generalize 15 raised to 6 into anything will give you the same. Now I am asking you 15 raised to 98 by 7. What is the remainder? So I am looking to find the closest number which belongs to the series. That means 96. So 15 raised to 96 by 7 will give me remainder 1. I know. How much left out? 15 square is left out by 7. What I need to do? I need to do this thing 15 by 7 2 times. That is what you are doing in terms of step. First you will do 15 by 7. Second what you are doing, divide the power of numerator by Euler's number of denominator. Why? Because you are looking for what is the closest number which will satisfy this condition, right? So you will get the answer. So what if the question was 20 by 7 raised to, let's say, 18. Now the idea is, if this is 20 by 7 raised to 6, these two are coprimes, right? HCF is 1. 6 is Euler's number of 7, means number of coprimes less than 7, right? So you know your remainder is 1. So 20 raised to 12 also remainder will be 1. 20 raised to 18 also remainder will be 1. So basically 20 raised to 18 by 7 remainder will be 1. What if 20 raised to 20 by 7 remainder is fast? You know 20 raised to 18 will be 1. You just need to find 20 raised to 2 by 7 now. You can do it easily. So what we have done till now, we have discussed about basic remainder theorem. We have discussed about Fermat theorem and how to apply Euler's number in Fermat theorem, right? And we solved basic questions as well as the higher level questions, right? We have also seen 2 raised to n numbers. How will you factorize and how to get the answer, right? So basic remainder theorem, what we have done, we have discussed that if a number can be factorized and can be written as like a into b or a plus b, in this case the actual remainder will be the product of individual remainder, or actual remainder will depend on the product of individual remainder. If the product of individual remainder is less than the divisor, you take it as a remainder. If it is greater than the divisor, divide it again by divisor and see what is the remainder. Same as the case with sum of numbers also, right? Then how you solved by applying Fermat theorem? We know that two prime numbers, let's take 13 and 7, two prime numbers as the numerator and denominator, and the power of numerator as the Euler's number of denominator, that is, let's suppose 6. Your remainder will always be 1. Okay, now along with this, when you apply the basic remainder theorem also, that means if you can factorize the questions like 13 raised to 12 by 7, it will become 13 raised to 6 into 13 raised to 6 by 7. So here you will get 1, here also you will get 1. So 1 into 1 is equal to 1. Then I told you anything which is coming in this series like 6, 12, 18, 42, 84 or whatever it is, or 96 for that matter, remainder will be 1, right? So if you write 13 raised to 96 by 7, remainder is what? 1. The reason is 96 is a series. The reason is 96 is a part of, you know, if you form a series with this number 6, 12, 18, it's a part of that. It's a multiple of 6, I can put it in that way. And what is 6? 6 is nothing but Euler's number of 7, right? So I understood that 13 raised to 96 by 7 remainder will be 1. What if it is 13 raised to 97 by 7? Then I will just write it as, what is my answer? Up to 96 we know it is 1. Now based on 13 by 7 I can write the answer. If it was 98, up to 96 I know. Now based on 13 square I can mark the answer. Now here again if you want you can apply basic remainder theorem rather than solving 169 by 7, right? How will you do that? You will write it as 13 into 13 by 7. 13 by 7 you know the remainder, 13 by 7 you know the remainder. Product of individual remainders, you get it. Okay. Now let's try this question. Let's take n is equal to 8888 raised to 6789. N is equal to 8888 raised to 6789. Okay. Now I can make different stories. This n is written in a blackboard, or a person is coming and adding the sum of digits and writing another number. So b is actually sum of digits of n. Then after he left, another person is coming and he is taking the sum of digits of b and writing c. So what is c? C is sum of digits of b. Now this process continued, different people will come, take sum of digits, and finally when you take sum of digits you get a single digit, and that you get as x. X is single digit, right? X is x itself, that means only one digit, single digit. So basically you have a number, what you are doing, you are taking sum of digits of that number, you keep on doing that till you get a single digit. The question is what is x? Or what is that single digit? How will you find it? What is the answer? So basically the moment you see sum of digit till you get a single digit, what you will relate it to? Where you have seen sum of digits? We have seen in the divisibility rule of 3, 6, 9, etc. right? But where I have discussed with you sum of digits till get a single digit, I have discussed it in divisibility of 9, right? See, generally what you apply in case of divisibility of 9, 383. Okay. You need to check whether it is divisible by 9 or not, or you need to see divided by 9 what is the remainder. What you do, you take sum of digits, right? 3 plus 8, 11, 11 plus 3, 14. Then you check 14 is divisible by 9 or not. No, then it is not divisible. Or you check 13 divisible by 9 divided by 9, what is the remainder? 5. That you will write as answer. But what is the other method which I have told you? You got sum as 14. Again you take sum of those digits, right? You get 5. So if you get sum of digits, if you take sum of digits till you get a single digit, what are the possible digits you get? You get 1, 2, 3, etc. up to 9, right? 0 you won't get because there is a number and you are taking sum, you cannot get 0. So the idea is if you get 9 as the sum, when you take sum of digit till you get a single digit, that number is divisible by 9. 0 remainder. If you get any other digit, that is the remainder when the number divided by 9. That means here you got 5, right? What does this mean? When you divide 383 by 9, you get remainder 5. So finding the sum of digits till you get a single digit will actually give you remainder when divided by 9. You have a number n, you find the sum of digit till you get a single digit, you got the single digit. What does it mean? It means that number when divided by 9, you get that number as a remainder. That single digit which you got when you take the sum of digits, you will get as a remainder when divided by 9, right? If that is the case, I can change my question like this. This bigger number divide by 9, what is the remainder? Okay, so this bigger number divide by 9, what will be the remainder? That will be the sum of digits till you get a single digit, right? So what is that single digit will be the remainder. So if you know what is the remainder, you can write this as answer because both are one and the same. The last single digit that you are getting, or if you find the remainder when divided by 9, if you know, both are same. So my question will become 8888 raised to 6789 by 9, what is the remainder? Now how will I find the remainder now? Now we have different methods, right? So what I'll do is, what is my first step? Numerator without power by denominator, right? So 8888, what is my first step? 8888 by 9, what is the remainder? So a number divisible by divided by 9, what is the remainder? How will you get it? Sum of digits till you get a single digit, right? You add 8888, again add till you get single digit, right? 8 is 4 times, so 4 into 8, 32. 32 is the sum of digit. Again add 3 and 2, you get 5. So what is 5? 8888 divided by 9, remainder is 5. Now what you need to do? 6789, that is the power of numerator divided by Euler's number of denominator. Now we are going to apply Fermat theorem, right? Divided by Euler's number of denominator. Right, now how will you find Euler's number of denominator? Denominator is 9, which can be written as 3 square, right? So your Euler's number of denominator, which is E9 I am representing, 9 number into 1 minus 2 by 3. You know the formula, right? E raised to n is equal to n into 1 minus 1 by a. If only one number. If b is there, 1 minus 1 by a into 1 minus 1 by b. If c is there, 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c, right? So here I have only one, right? 3. So 9 into 1 minus 1 by 3, that means 9 into 2 by 3. So you get 6 as the Euler's number of 9. So I need to divide. What is my second step? I need to divide 6789 by 6. What is this? The power I am dividing with the Euler's number of denominator, right? We have discussed this method earlier. Enough discussion is over. Enough example is also solved. Okay. So 6789 divided by 6. Now here, rather than dividing, you can apply the divisibility rule of 6, right? So divisibility rule of 6 means last digit should be even. At the same time, number must be divisible by 3, right? Divisibility rule of 3 is sum of digits, right? So here you need to find the remainder and divide by 6. So divisibility of 6 is divisibility of 3 and divisibility of 2, right? Combination. You need to check whether it is divisible by 3 or not, or 2 or not. So here it is odd number. It is not divisible by 2. Let's see whether it is divisible by 3. When you take sum of digits, you get 30. What does this mean? This number is divisible by 3 but not by 2. Okay. Now, if you take the previous multiple of 3, then you will get as 6786. If you get the previous multiple means just subtract 3. Okay, so previous multiple of 3 if you take, because I understood that this is divisible by 3, it's a multiple of 3. If I take the previous multiple of 3, I get this. This is the number which is divisible by 3, at the same time it's an even number, so it's divisible by 2 also. So if it is a divisible by 3 and divisible by 2, then I can divide it by 6 also, right? So this is a number which is divisible by 6. So from that, if you look into the difference, I can find what is the remainder. Remainder is 3. See, this much complexity is not there. Just to make you understand, I have discussed this much. See whether it is divisible by 3 or not is what you are checking, right? If it is divisible by 3, not by 2, you just subtract 3. The previous will be a multiple of 2 as well as divisible by 3. I can take it as multiple of 6. So the difference is 3. I get the remainder as 3. So what is my answer? This 5 raised to this 3. 5 raised to 3 is my answer. Or my answer depends on 5 raised to 3. Okay. So 5 raised to 3 is greater than the divisor 9. So what I need to do? 5 raised to 3 is 125. I need to divide it by 9 again. So do you need to divide and find the remainder? No. Take the sum of digits again, because divided by 9, sum of digits is the remainder, right? If it is if you need to divide by 9, sum of digits is the remainder, right? So 1 plus 2 plus 5, you get 8. So answer for this question, that is 8888 raised to 6789 divided by 9, what is the remainder? 8. What is the answer for the question which is asked? That is also 8, because if you take sum of digits, still you get a single digit, that will be 8. That is nothing but remainder when divided by 9, right? So how you did that? A quick recap for those who did not understood. We changed the question like 8888 raised to 6789 divided by 9. What is the remainder? Right? Now this question I can solve by using the concepts which I have learned. I can factorize the numerator. I can apply basic remainder theorem. I can apply Fermat theorem by applying Euler's number, etc., etc. Right? So if that is the case, what is the first step? First step is numerator by denominator without power, right? So 8888 by 9 is what I need to do. So I know this is nothing but sum of digits. I get it as, so if I perform the first step, I get it as 5. Second step, I need to divide the power with the Euler's number of denominator. We got the Euler's number of denominator as 6. So you divide 6789 by 6 and you apply the divisibility rule of 6 and you got remainder as 3. Then what is your answer? 5 raised to 3. Since 5 raised to 3 is greater than the divisor here, what you do? This is nothing but 125, right? So you need to divide it by 9 again. So rather than dividing it by 9 to find remainder, you can just add the sum of digits. That's what we did and we got the answer as 8. Okay. Now what we discussed is, had it been instead of 6789, had it been 6786, what would have been the remainder? Remainder would have been 1. Why? That is what we discussed under Fermat theorem, right? See, 8888 divided by 9, right? This, if it was 6, what is 6 and how 6 and 9 related? 6 is the Euler's number of 9, right? So if this was 6, the remainder in this case will be 1. That's what Fermat theorem. So now if it is 6, it is 1, remainder will be 1. If it is 12, then also remainder 1, because then we are applying Fermat theorem along with basic remainder theorem, right? So if it was 12, how will you write? You will write it as 8888 raised to 6 into 8888 raised to 6, right? Divided by 9. Now in the first case you get 1 as a remainder, second case also 1 as a remainder. So 1 into 1, that's what basic remainder theorem. You get again 1 as a remainder. So now you can extend it, right? 8888 raised to 6 or 12 or 18 or 24 or 48 or 96. What you'll get? You'll get remainder as 1. So anything which is a multiple of 6, if it comes here, you get remainder 1. Here 6786 is a multiple of 6. That's why if that was the power, then remainder would have been 1. So what we understood is, up to 8888 raised to 6786 divided by 9, it is 1. Then how much is left out? In our question it was 6789, right? So what is balance? Balance is 8888 raised to 3 by 9. Why? Because see, I can split 8888 raised to 6789 by 9 as 8888 raised to 6786 into 8888 raised to 3 divided by 9, right? Now in this case I know the remainder is 1 because this is a multiple of 6. Then it satisfies Fermat theorem, right? Then what I need to find is the remainder of this. Then I get the answer. So remainder of 8888 raised to 3 divided by 9 is was effectively you need to find out in this question. That's why you are applying that method. Okay. So how you are doing it? 8888 into 8888 into 8888 divided by 9. So each case you can find the remainder, right? So you don't want to find it by manual way. You can just add the sum of digits. You get 5 into 5 into 5. This is what you get, right? So this is nothing but 125, which is greater than 9. So further divide by 9. Take sum of digits again. You get 8. So this is what we are doing, right? So what you are doing actually is, the first step is to get this 5. 8888 by 9. What is the remainder? That's what you are finding, the first step. Second step, how many times you need to do? Because here you understood 6786 is a part of 6, that series. After that, how much is left out? 3 is left out. How to find it? You take the power of numerator 6789, divide by Euler's number of denominator by 6. See what is the remainder. That many times it will come finally 8888. So that's why finally you are doing this 5 raised to 3. So what we have done till now, basic reminder theorem. Then if numerator is factorized, how to find the answer. 2 raised to n numbers we have seen, right? We have seen Fermat theorem. I have also discussed the application of Euler's number in Fermat theorem. Now divisibility of 9 is something which we have already discussed in divisibility rules, and here also I have discussed a question, right? See, basically divisibility of 9, you can get a lot of questions, right? You can get a question like the one which we have asked, sum of digits based questions, right? Because here n was given and sum of digits based question is given. Or they can ask you a question like, there is a number, they won't give you the number. In the previous question they have given you the number 8888 raised to 6789, right? Now they will tell you there is a number which when you take the sum of digits, you get another number, again you take sum of digit, another number, again you take sum of digit, another number, finally you get a number single digit which is x itself. That means it's a single digit, and that in this question they can give you that single digit, let's say 7. In the previous question they have given you the number and asked you to find the single digit. Here they are giving you single digit and they will ask you to find the number. They cannot just ask you to find the number, because this number, there are many possible numbers which satisfy this condition. 7 itself is the number, right? Then if you add 9 to it, 16 is another number which satisfies the condition. 1 plus 6 is 7. If you add 9 to it, another number. If you add 9 to it, another number. All these satisfy the condition of sum of digits 7, right? So there are many possible numbers. They can ask you within a particular range how many such numbers are there. So within 100, how many such numbers are there. Now here if it was a question like that, how many such numbers are there less than 100? When you take sum of digits, it will be 7. What you will do? See, you need to observe here. You are getting an AP, right? AP with a common difference 9. Here also 9. Here also 9. So you are looking for, see, and what is the speciality of these numbers? All these are multiples of 9 minus 1. So you are looking for a number just less than 100 which is a multiple of 9. We know that it is 99, but 99 is not a part of the series. 99 minus 2 is what the part of the series, right? So 97. Now if you take sum of digits, 16. 16 means 1 plus 6 again if you do 7, right? So 97 is the last number which will come in the series. The condition is less than 100. If I can extend it to 1000, then more numbers will come, right? So 97. Now you know the first term, you know the last term, you know the common difference 9. You can find how many terms are there, right? Last minus first divided by common difference plus 1. That's your answer. Last is 97. First is 7. So 97 minus 7 you get 90. 90 by common difference which is 9. That will give you 10. 10 plus 1 will give you 11. So how many such terms are there in this series? 11. So how many numbers have digit sum 7 within a range of 1 to 100? 11 such numbers are there. Or they can ask you a different question, simply a number which when divided by 9, what is the remainder? First possible question is like based on digit sum of digits, right? Or they can ask you a question based on AP with a common difference 9. So all these can be asked from the divisibility rule of 9. So till now what we have covered is the situations where you can factorize the numerator. We have discussed different methods. Now we will see if the denominator is larger, okay? If you need to factorize the denominator, how will you proceed? That's what we are going to see now. Let's suppose number is like 2 raised to 37 divided by 99 or something like that. Or if it was 77, something like that, right? So here you need to factorize, you can factorize the denominator as 9 into 11. Or you can factorize it as 7 into 11, like that. Okay, then what is your answer? How will you proceed? If this is the situation, how will you proceed is what we are going to see next.